This lesson's on approximating square roots, but before we begin, we're going to go over some vocabularies. Now, looking down here in the picture, there is the real numbers, and in the real numbers, there are two sets of categories. One is called the rational number, and then the other one is called the irrational number. Now, notice in the rational number, there are also different levels. So one of the level is called the natural counting numbers, which are numbers that you learn in elementary school, and you naturally count 1, 2, 3, 4, 5, etc. Later on, you start to learn about the zero number. When we talk about whole numbers, that is including the zero and the natural numbers as well. And then later on in middle school, we learn about the integer. So integer numbers are your negative numbers. So we start from the negative number, then we go to the zero, and then we go to the natural counting numbers. Usually this is introduced in our number line. Now after that, we go into more of the rational numbers, and those become the fraction. Now this is the two parts that is different between the rational and irrational. When you have fractions, they have to have a terminating, meaning that the decimal stops, or it repeats the same pattern. So if it falls in that category, like 1/2, when we put it into a decimal, this becomes 0.5. It stops right there, so that this becomes a rational number. In -2/3, our decimal becomes negative 0. And then the 6 keeps on going as a pattern. Even though it keeps on going, it is a pattern. So this becomes a rational number. Same as that 0.3, that is a pattern that keeps going, but as long as it's a repeating pattern, this becomes a rational number. Now on the opposite side, which is the irrational, notice the irrational numbers are numbers that have decimals that do not repeat the same numbers, or they do not stop, they do not terminate. So for example, like pi, it's a number that continues on, so it does not have a same pattern like we did with the -2/3, or it does not even stop as well. So same thing with this one. And then this right here, same thing. If you find the square root of 3, negative square root of 3, this is a pattern that will continue on as far as your decimals goes. And then also right here, the cube root, if it is not a perfect square, so same thing with this right here. We've talked about perfect squares in 7.1 and 7.2, where if you have 2 or 3 of the same perfect square numbers, they come out of the radicand. But if they do not have that matching pair, then they stay inside the radical sign, and so then they become an irrational number. Now let's look at example 1, and we're going to classify the real numbers. So in A, is 0.121221222 a rational number or irrational number? It will be considered an irrational number, although you may see some kind of a pattern of a 1 and 2, but it is not a consistent of the same pattern, like the 0.333 or the 0.666. Those are the consistent patterns, and this is not the pattern. This grows as far as the pattern goes, so this is not a rational number. Let's talk about B. Is B a rational or irrational number? In this case, it is a rational number, because if I take the square root of 196, and if I do a division ladder for this, then 196, we can start with a 2, and 2 goes into 196 98 times. Since 98 is not a prime number, we would do another round of the division ladder, and 2 would go into 98 49 times. 49 is not a prime number, so we would do 7. 7 goes into 49 7 times. So inside we would have 2 times 2 times 7 times 7. And we can see there's a group of 2's that will come out, and a group of 7 will come out. These are called now perfect squares because they all come out of the radicand. And so 2 times 7 equals 14. So that becomes a -14. So because it is a integer number, This is now considered a rational number. Now let's look at letter C. Is C a rational number or irrational number? It is considered a rational number because the decimals terminate, which means they stop. Now let's look at letter D. Is 3.141592654 a rational number or irrational number? It is considered an irrational number. In fact, this number is pi, and so as you can see, there is no pattern to this decimal numbers, and it continues on right there. Now let's look at example 2. We're going to go ahead and estimate the square root of 71 to the nearest integer and the 10th place. If I take the number 7 and I square it, then 7 times 7 will give us 49. So we're going to go ahead and put 49. And then do the same thing for 8. So 8 times 8 is going to give us 64. And 9 times 9 will give us 81. 10 times 10 will give us 100. So these are all inside the square root right there. When we square it, we're talking about being inside the square root. So now when we compare the square root of 71, it would have to be between these numbers right here as far as the 71 because it's between the range of 64 and 81. I would put 8 and square root of 64 and then 9 and square root of 81. Now, to be more specific, I would try to find the halfway point. If you multiply 8.5 times 8.5, that would give us a square root of about 72.25. So you can see right there that the square root of 71 would have to be a little less than the halfway point. So this right here, square root of 71, would belong approximately there. In example 3, it is asking us which is greater, the square root of 5 or 2 and 2/3. So similar to example 2, I want to have a number that we can have a range. So square root of 5 would have to be a number that is between square root of 4, which is a 2, and then we could do a range of 3, which is a square root of 9. And then try to fit in between that. So we have then square root of 5 is literally right next to that square root of 4. So that would be a place value right there. And then halfway between 2 and 3, so somewhere around here, would give us about 2.5. And if I look at 2 and 2/3, I can convert the 2/3 into a decimal. And so that gives me 2 inside, 3 on the outside. 3 cannot go into 2, so we introduce the 0 in a decimal place. And so then 3 goes into 20 6 times, giving us 18. And if we subtract that, that's going to give us 2. 3 cannot go into 2, so we bring down a 0, and that will give us another 6. So this becomes a repeating number. So if I add this 2 to the 0.66, that's going to give me 2.66. And 2.66 is a little bit more than half, so it would belong somewhere around here at 2.66. Having those two numbers on the number line, I can visually see which is greater. The number that would be greater would have to be 2.66 because it is closer to the 3 right there.